Hello. So this lecture will be on solving one-step and multi-step equations. We'll go over some basic definitions, and then I will solve 10 examples with you, and then your assignment will be 10 examples. So this video will be the lecture and the assignment together. Okay. So it's just a review of you inverse operating and combining like terms and just knowing which is which. But they're pretty elementary right now. It's just to get you back into solving. Okay. All right. Here we go. Okay. Okay, solving one-step and multi-step equations. What is an equation? It's a math statement, right? It's a mathematical sentence that the value, so it is a statement that the values of two mathematical expressions are equal, and they're indicated by that equal sign. This equal sign, which is a symbol, right? Okay. Inverse operations, it's an operation that reverses the effect of another operation. For example, addition and subtraction reverse each other because they're opposites, right? Addition and subtraction. So positive 3 versus negative 3, you get 0. That's the intended goal. Multiplication and division. If I multiply, if I get the product of these opposites, so multiplication and division are vice versa, are inverse operations and vice versa. 3 times 1/3, right, gives me 1. That's the intended goal. So when you're solving multi-step equations, you have to know what inverse operation to use, which, you know, for multi-step, you got to take the term and you have to jump the equal sign. Okay, so combining like terms, or CLT, because it's kind of long to write, so combining like terms. It's a technique used to simplify expressions/equations. Okay, what do I mean by that? Expressions is what we did on the distributive property. There were no equal signs. You just multiplied, and then your answer was a two-term answer, a two-term solution. There was no equal sign present. That's an expression. When an equal sign is present or it exists, it's an equation. So this entire assignment, you're going to see equations because you see an equal sign. Okay, so that's the difference between the two. Here you simplify, here you solve. Okay, those are typically the directions. Okay, so inverse operations versus combining like terms. When you see the like terms and they're on opposite sides of the equal sign, that's inverse operations. So you're going to do the opposite of the sign that you see. Combining like terms is when they're on the same side of the equal sign. This is the one we're going to practice, not this one. Okay, so combining like terms will be later on, and that's when you honor the sign that you see. Okay, here you go opposite, here you honor what you see. Okay, so remember, an equation has a left side and a right side because here's the equation, here's the equal sign, right? This is the equal sign. And so it has left and it has a right side. And so typically there's two terms somewhere or one term, right? That's what we're dealing with. Okay, there's a right and a left side. Okay, next. So now we're going to solve. Okay, so here we're going to go ahead and solve. Let's solve for x. I got a little excited and I went straight to let's solve f(x). Let's solve fox. I just, got a little excited and went, let's solve fox. Okay, so here we go. You have x plus 3 is equal to 10, so this is our equation, right? Okay, this is my variable term. So when you're going to solve, you want to tell me what x is equal to exactly. So you want to isolate the variable term. Now, my coefficient to x is 1, so this is just x. So this is a one-step equation. So if I want to take this constant 3 and combine it with this constant 10, right? So they are like terms. But remember what we said. When the like terms are on opposite sides of the equal sign, you inverse operate. So you're going to go ahead and take the opposite. And remember, since we're dealing with positive and negatives here, right, our goal is 0. And what I mean by that is I want to take this positive 3 and I want to go ahead and move it over to the right side because positive 3 is on the left side of the equal sign, right? I want it on the right side of the equal sign, right? So typically you just kind of make a dash And then you can see this is the right side, this is the left side. So this constant 3 needs to combine with this constant 10, but I'm going to inverse operate. So here I'm going to inverse. So if this is positive 3 or addition 3, what's the opposite or the inverse operation of positive or addition? Subtraction. So I'm going to subtract 3, right? Which basically comes out to negative 3. And so what's positive 3 minus 3? 0. So that's my intended goal, is to make this disappear or essentially sum to 0. Okay, and so now what's my answer? X is equal to positive 7, right? So I bring the x down. This is 0. What's 10 minus 3? I get the 7, and so that is my answer. Correct. Okay, remember, this is all review. All right, again, where's my equal sign? My equal sign is right here. So I have a left side, which is x minus 8, and I have a right side, which is positive 12. Again, this is a constant, negative 8. This is a constant, positive 12. I want my constants to combine, but if they're on the opposite side of the equal sign, I need to inverse operate. So I'm going to, inverse operate here. And so this negative 8 needs to come over here. But if I'm going to jump that dashed line or jump the equal sign or move from the left to the right, you got to change the sign. So if this is negative 8, positive 8, positive 8. And so now what do I have? X, this is 0, equal sign, and what's 12 plus 8? 20. And there's my answer. Right? So here I added 8. Okay, so now here, this is a one-step equation. I have 5x equal to 20. Again, this is my equal sign. I have a left side, which is 5x, and I have a right side, which is 20. I want to know what x is. Not 5x, 1x. That's when we say x, I want to know what 1x is. So I need to inverse operate this 5. So if this is 5x, what do? Well, this is kind of a multiplication of 5. So you're going to go ahead and inverse operate. And what am I going to do? I'm going to divide by 5, right? So divide by 5, divide by 5. And some of you that are thinking, oh, reciprocal it, and so go 1/5, 1/5. That's fine too. That's the same. Okay, so divide by 5, and I get x is equal to, and 20 goes into 5 4 times. Okay, next, same here. Where's your equal sign? You have to know where your equal sign is. So I got negative 2x on the left, and I have 12 on the right. So I want x by itself. So I'm going to divide the negative 2. Remember, do not take the x with you, just the 2. And so negative 2 divided by negative 2 is positive 1, right? A negative divided by a negative is positive. And what is 12 divided by negative 2? Negative 6. And remember, there's nothing wrong with you grabbing a calculator and either going 12 divided by negative 2. There's my negative 6. Or you can hit this fraction bar and put 12. Where is it? Oh, there it is. Down negative 2. I didn't realize the light was shining on the bar. And you get negative 6. So again, on this calculator, you can use the fraction button, or you can go ahead and use the division. It's fine. Either one. Remember, there's no shame in using a calculator. Okay, here. Now this example. Here is my equal sign. I have a left side, which is negative x. I have a right side, which is positive 4. I want to know what x is. Solve for x. And when I say solve for x, I want the coefficient to be positive 1, not negative 1. So this is really a negative 1, right? So your coefficient is negative 1. Go ahead, inverse operate it. So divide by negative 1, divide by negative 1, and I get negative 4. And you're typically really good at this. Oh, wait. Divide by negative 1. We're going to inverse operate here. I didn't realize I didn't put that. I got ahead of myself. Okay. Right. Okay, so here, this is where most of you would probably reciprocal, right? So I'm going to go ahead and reciprocal, and that is 3/2. So it's when you flip the fraction, right? What's the numerator becomes a denominator, and what's a denominator becomes a numerator. And that is what you're going to multiply to both sides of the equation, right? So remember, what you perform on the left, you have to perform on the right in order for you to keep this equal symbol, this equal sign equivalent, okay? All right, so 3 divided by 3 is 1, 2 divided by 2 is 1, or you can multiply 3 times 2 is 6, 2 times 3 is 6, so what's 6 divided by 6? 1, right, positive 1, so x is equal to, and now here 2, right, divides into 10 5 times, and what's 5 times 3? 15. Because we're going to be solving systems of linear equations, and when you get to the third method, which is solving by linear combinations, you end up having to multiply distributive property and possibly working with fractions, okay? Not too many of them, but we will. Okay, you have negative x here. So now we're in two-step equations, right? So there's my equal sign. Okay, I have this positive 3. It's a constant. I have 11. It's a constant. I need to take this 3 and I need to take it over. And so what's the opposite of positive? Negative 3. And so whatever you perform on the left, you perform on the right. Okay, so now I get negative x. This takes me to 0. Equal sign, 11 minus 3 is 8. Okay, but you're not finished here. I want to know what x is. Positive x, not negative x. So this really has a 1 here. And so some of you would just switch the signs, but technically, right, we're going to divide by negative 1. And so x is equal to negative 8, right? And if you did it another way, if you multiply negative 1 to both sides, you're fine. Okay, if you just switch the signs, you're fine too. That just means you understand what you're doing. You just master that concept. Okay, again, here's my equal sign. This is the left. This is the right side. Again, here's a constant, positive 5. Here's a constant, positive 8. I want to take this constant and I want to combine it with that positive 8. But what is the opposite of positive 5? Negative 5. Why am I taking the opposite? Because the two constants, or the two like terms, are on opposite sides of the equal sign. And so that's when you change them. Okay, so negative 5, I get 3x, because this goes to 0, equal 8 minus 5 is 3. You're not finished. I want to know what x is, not 3x. So how do I get rid of that coefficient? How do I make that 3 become a 1 coefficient? You divide by itself, right? Because multiplication and division are inverse operations. So that gives me 1, and this gives me 1. So x is equal to positive 1. Okay, last two. I know this is kind of a long. All right, so here we go, a long video. Okay, so there's my equal sign. There's a left side, there's a right side. Okay, I want this constant to combine with that constant, negative 1 with the positive 9, but because I have to jump that equal sign, that dashed line, what's the opposite of negative 1? Positive 1, which you do to the left, you do to the right. So this gets me to 0, so I get 2x is equal to, and 9 plus 1 is 10, but you are not finished. I need to inverse operate this 2 because I want to know what 1x is. I want to know what x is, not 2x. So I'm going to inverse operate it, which means you're going to divide, and so x is positive 5. Okay, and here we go again, last one. Okay, left side, right? I have a positive 6. And a positive 14. I want the 6 to combine with the positive 14. So I'm going to inverse operate, which is negative 6, because what's the opposite of positive 6? Negative 6. So this takes me to 0. So 5x is equal to 14 minus 6 is 8. Now here you're going to get a fraction. I did that intentionally, right? So I'm going to divide by 5. I get 8/5. Remember, as we move on in math, you're going to get fractions and decimals. It doesn't mean that you are incorrect. So if you want to take the 8/5, and okay, so on this button, this is the reason why too I wanted to use that. There's an SD, which is scientific to decimal. Click that, and every time I hit, see how it goes from decimal to fraction, which is scientific. Okay, decimal, scientific. So each time you press that, it switches. Okay, so that's why we love these calculators. This button and this button. These two are winners. When I went over trigonometry, when I showed you guys the modules, these are the 3 buttons that you're going to use, and these little yellow with the -1, cos -1, like that. Okay, that's just showing you. But that's why this is a great calculator. Okay, I think it was 1.6, right? Yeah, 1.6. Okay, so it's up to you how you want to express this answer to me. For this assignment, I don't have a preference. So you can give me 8/5 or you can give me 1.6. Don't give me 1 3/5. Don't do, this is an improper fraction. This is a decimal. You don't have to give me the mixed number with the 1 3/5. You don't need to give me that, okay? Okay, so here's your assignment. Let's hurry up and get to it because this is already 16 minutes long. Okay, so here's your assignment. You're going to go ahead and solve for x. So you're going to inverse operate, know where the equal sign is, know where your constants are. Go ahead and take the opposite. Remember, when you jump the equal sign and you're talking about constants, you change the sign. I'm just going to slowly move over this assignment. So I tried to make them identical to the examples that I did for you. I know my nails look terrible, sorry. Okay, decimals or fractions are okay, just like I did here. So it's up to you. You can take the fraction or you can take the decimal. Okay, I painted this weekend, so they just got totally messed up. All right, here we go. Fair enough. Okay, when I put this into Canvas, I will have it where you can take a picture and do that Dropbox in the assignment submitted through Canvas. But if you still do it through Remind or you send it as an email attachment, that's fine too. But I will have it for these 2 assignments. Okay, all right, have a great day, guys. I'll see you soon over Zoom. Okay, bye-bye.